G'day Internet, my name is Andrew Russell and welcome to Stick Ninjas DevLog episode 32. First of all, you might be wondering whatever happened to my Let's Examine series of videos, and basically I've had to cancel those because they were taking way too long to produce. As you may know, I keep fairly close track of my time. I use time logging software, so I know how much time I'm spending on things. So just to give you an idea about how long video takes to produce, these devlog episodes take around half an hour to produce 1 minute of footage. So a typical 6-minute devlog episode takes around 3 hours to make. And that includes time to write the script and then film it, capture all the gameplay footage and then edit it all together. The mini devlog episodes that I was doing recently, they were a bit less efficient and they were taking about 1 hour to produce 1 minute of footage. But because they're only 1 minute long, that's all right. And so I was hoping that the longer Let's Examine videos would be more efficient to produce, but actually they're not, because I was going for basically a higher production value. So what I was finding is that it was taking about, well, over an hour to produce 1 minute of footage for that, and then the scripts for Let's Examine were about 20 minutes long each, and so that's 20 hours per video, which is a lot more time than I really want to be spending on what is basically a side project. So I've really had to cancel that so I can spend more time on Stick Ninjas. And so, you know, I might come back to it. It probably would take maybe a Kickstarter or something, or I could like change formats and do a blog. But for the time being, I've just left that and I'm going to keep working on Stick Ninjas, and spend more time on it. So, given that this is the Stick Ninjas devlog, we should go and take a look at that. So what I've basically been working on is trying to find a fix to this problem, which is basically where the client and the server gets different ideas about which direction the player should be moving in. And because of the way prediction works, the client can actually have many different ideas over time about where the player should end up. And so I've added a few features to the game to make it easier to sort of diagnose this problem. So first of all, there's live level editing. So I can make changes here to the level, and the graphing tool will go ahead and recalculate the entire path and the way the game works on that particular level. I've also added this feature to the network simulator, so I can go in there and edit in there as well. And this lets me quickly put together test cases so I can make sure that the networking and the physics are working together correctly in sort of all the weird edge cases that are possible. The other feature that you might have caught a glimpse of in the last devlog, I didn't explain it back then, but basically you can see this brown line flickering along the path here. And this basically shows the path that prediction is taking. So if you recall the way prediction works, every time a packet comes in, the client will load up that state and then go ahead and replay all of the inputs from that frame onwards to get the predicted state. And the upshot of this is that the client player will instantly respond to the user's inputs rather than waiting for a round trip to the server. So you can see if I hover over only the snapshot packets coming down from the server, you can see that every one that comes into the client will generate this prediction. And you can see here that this shows the cause of the glitching problem, basically because sometimes prediction will give one result and sometimes it will give a different result. And this basically comes down to quantization errors, because whenever the server goes to send something off to the client, it actually strips off some of the precision so that it takes up fewer bits on the network. But this means that the position and the velocity that the client is using to start its prediction from will be slightly different to what the server is using. And this can end up giving extremely different results, particularly for longer amounts of prediction, which is basically whenever the client has more lag. So you can see here, if I zoom in, the position value on the server is just slightly different to the position value that the client is using to start its prediction from. And then the end result is actually different to what the server got in this particular case. But in other cases, the client gets the same result as the server. And on the client, this results in the player sort of jiggling up and down. So what you can see here is my first attempt at fixing this. And the way this works is the client is actually sending position and velocity data back to the server at full precision. And then the server is validating that data and making a choice to use that particular full precision data instead of its own. And unfortunately, the upshot of this is that the client actually skips and jumps around a whole lot because I've basically what I've created here is a feedback loop. And so the player's position just keeps stuttering around more and more until the netcode actually has a problem with just how much it's stuttering and gives up. So I've got an alternate technique to try and make this work, and I'm currently working on implementing that now, and it involves some deeper changes with the physics engine and how that integrates into the networking. So that's still a work in progress, so hopefully I'll be able to show you that next episode. But for the meantime, go to stickninjas.com to sign up to get a notification when Stick Ninjas is available for playable pre-order. And otherwise, subscribe to my blog at andrewrussell.net and follow me on Twitter at _AndrewRussell to get development news. Thanks for watching, and I will see you next time.